Welcome to 48th lecture. In this lecture, we'll study average or active power in terms of RMS quantities. Up till now, we have been studying average power in terms of peak quantities. Shortly, I'll tell you what's the difference between the peak and the RMS quantity, the root mean square quantities. Right. So we have studied that power is 1 by 2 times Vm Im cosecant of theta v minus theta I. It's a small recap from our last lectures. For Rs, for resistors, we have already studied that the voltage drop, the complex quantity referring to the voltage drop across resistor is Vm at an angle of theta v, while the current flowing through is Im at an angle of theta I. We have studied in our previous lectures that for resistors theta v is equal to theta I. This is not true for inductors and voltage sources and capacitors, etc., but it is true only for resistors. So cosecant of theta v minus theta I means cosecant of 0, this is 1. So when putting 1 instead of cosecant of theta v minus theta I in this equation, we get this equation. Power is 1 by 2 times Vm Im, but I have mentioned it again that it is for resistors only. V and Im are peak values. For a sinusoidal signal, the peak value achieved while it is in its positive half cycle or in its negative half cycle. The magnitude of the max power of the max value achieved by a sinusoidal signal is its peak value. The RMS value we have studied in last lecture is 0.707 times the peak. This means it is the RMS value is slightly lesser than this peak value, maybe this value. This is 0.707 times 70%, approximately 71% of this peak value. So this is slightly smaller, this RMS value is slightly smaller than the peak value, right? So since for using Ohm's law, we can write the voltage drop across resistor is the product of current flowing through it times its resistance. If we plug this value in here and here and this, we get a new power, a new expression for power, which is 1 by 2 times, now Vm has been replaced with, Vm is replaced with Im times R, so it gives us a new power which is 1 by 2 times Im squared R, right? Or Im, according to Ohm's law, Im can also be written as Vm over R. If we put this value of Im in this expression here, we get Im replaced with Vm over R. So now power can also be written as 1 by 2 times Vm squared over R. So we have these three expressions for power when we are computing it across in a resistor. So these are three expressions for power: expression number 1, expression number 2, and expression number 3. The answer in all these cases is the same, right? Let's compute these three expressions in terms of RMS quantities. RMS quantity was studied by us in our last lecture, right? We have studied that Vrms is 1 over square root of 2 times Vm, where Vm is the peak quantity. Or we can write Vm by multiplying square root to the other side of the equation. Vm is square root of 2 times Vrms. Similarly, if it is current, it follows the same lines. Square root of 2 times Im is square root of 2 times Irms. If you plug these values in expression number 1 that we have studied, this expression 1 by 2, this is expression number 1. If you put Vm and Im in here, this is 1 by 2 times square root of 2 VRMS from here, and square root of 2 times IRMS taken from here. So we get a new expression where square root of 1 over square root of 2 vanishes, and this new expression is power is VRMS times IRMS. Why we do not have this 1 over 2 terms? Because these quantities are not now RMS quantities instead of P quantities. So the same power, the answer would be the same once again. If we have to compute power using peak quantities, the expression would be this. But if we have RMS quantities and we want to compute power, the expression will be this. Similarly, for expression number 2 and 3, we can put these RMS values and we compute this expression IRMS squared times R for expression number 2, and working through on the same lines we get VRMS squared over R if we have only the voltage available. In case of peak values, we have a 1 by 2 here and 1 by 2 here. So if we have peak values, we have to put 1 by 2, and if we have RMS values, we don't need that. Right, this is all for today's lecture. In the next lecture, we will study something more about AC powers. Thank you.